Hello, everyone. My name is Gonyop Kim, and I'm here to present our paper, Mixplorer, Scaffolding Design Space Exploration through Genetic Recombination of Multiple People's Designs to Support Novices' Creativity. It is work done with my colleagues, Richard Davis, Alessia Coppi, Alberto Cattaneo, and Pierre Dillenbourg. Exploring design spaces is an important process when creating a design in any domain because it allows the designers to understand what is available in the space, which is critical in generating a novel solution. What motivated our work is the fact that exploring design spaces for creative practices can be often difficult. It can be particularly challenging for novice designers, as they do not have the experience or the expertise that expert designers do in order to perform the task. Therefore, we wanted to design a novel mechanism that can scaffold the navigation of design spaces for novices and help them explore a broader space of possible designs. The idea behind the design of our work is to recombine the different components of the designs created by multiple designers. Imagine I created a garden design, the domain that we focused on in this study, and you also created a garden. Our idea is to provide the designers with a tool that can recombine or mix their designs in order to generate many more designs so that they can explore a broader space of possible designs. So the core idea of the mechanism that we propose is called social design space exploration. As shown in this figure, by mixing each other's designs, novice designers who are often unaware of the full extent of the design space can end up exploring a much larger part of the space than they would on their own. The main hypothesis of our work is that this social design mixing can support novices' creativity and as a consequence, help them produce more novel subsequent designs by exposing them to a larger volume in the design space. So here is our application, Mixplorer, which we designed for the garden design domain. It starts with a design phase where users can create a garden design by simply drag and dropping items in the garden with a mouse. You can also rotate or delete any item using the keyboard keys. Once you have a design, you can move on to the next phase, which is exploration phase. In the design space graph on the left, you see a node of your own design, as well as those of your colleagues' designs. You can select two designs and generate their child designs using the design generator. You can slide left or right to see different variations where the position of the slider changes the probability of sampling the components of the two parents. Once you find the design that you like, you can add it to the design space graph and continue the process in order to explore the design space. One important element of the design of Mixplorer is the use of a human-in-the-loop approach in the design selection process. By using this approach, we do not have to explicitly define a fitness function for the genetic algorithm, which is often very difficult to have for subjective design domains, such as garden designing. It also enables a preference-driven exploration that is tailored to each user. And the design of our interface allows rapid navigation of a large number of designs in this user-driven process. Using Mixplorer, we conducted two studies. The first study was an interview study with design instructors, where the goal was to hear some expert opinions on, one, whether the teachers in the garden design domain would actually use Mixplorer, and two, whether they anticipated it would have some benefits for their students. As a result, regarding the feasibility of using Mixplorer in a classroom with students, all instructors were open to using it with their students, while most of them were quite enthusiastic. Another point was that 4 of the instructors mentioned its potential for supporting collaboration among those designers. We found this point quite interesting as it proposes another way of going social in design space exploration. The second topic in the interview was about the potential benefits of using Mixplorer for novice designers. 4 of the instructors believed that Mixplorer's design mixing process would support divergent thinking of the students. However, 2 instructors raised doubts about the value of the design mixing. They said seeing the designs of others is helpful, but they were not sure about the mixing part. We took this opinion seriously, and it actually motivated our second study. As the second study, we conducted a controlled experiment in order to investigate the value of the design mixing functionality of Mixplorer. Our research questions were, 1, whether design mixing can better support creativity in the design process. 2, whether they can produce more novel designs after using the design mixing functionality. For this, we recruited 66 novice designers and carried out a between-subject experiment with 3 conditions. All participants started with a design phase where they were asked to create a garden, followed by an exploration phase based on their conditions. And there was a second design phase where we asked them to create a design again. After that, they were asked to do a CSI, or a Creativity Support Index survey. For the results regarding the CSI measure, we observed significant differences in 4 of its 6 criteria: enjoyment, exploration, collaboration, and results worth effort. And for 2 of them, exploration and collaboration, the mixing condition was outperforming both the baseline condition with no exploration and also the random exploration condition, where the participants only saw random designs without mixing. The one factor that we were most interested in was the exploration factor, as Mixplorer was designed to support the exploration of the design space. And it was nice to see that the design mixing functionality provided better support for this. Another measure we looked at was the novelty of the design outcomes. For this, we defined novelty as the difference between the initial design and the final design. Therefore, it measures how novel one's final outcome is compared to their initial idea. Inspired by genetics again, we used Levenshtein edit distance to quantify this measure. As a result, we saw that after using design mixing, the participants were able to produce more novel designs compared to the baseline condition. So we observed the difference among the conditions in terms of the novelty of the design outcomes, and we wanted to understand better what was actually causing the difference. For this, we performed a mediation analysis, where the independent variable was the experimental condition, the outcome variable was the novelty of the design outcomes, and the mediator variable was the support for exploration measured by CSI. We found that the support for exploration was fully mediating the relationship between the experimental condition and the novelty of the design outcomes. This result confirms our hypothesis on the positive effects of design mixing on supporting the exploration of the design spaces, which in turn helps novices produce more novel designs. In conclusion, we demonstrated using Mixplorer a novel way to scaffold design space exploration for novice designers. After our interviews with design instructors, we investigated the value of the design mixing process in a control experiment, where we showed that it can provide novice designers with better support for exploration, which can lead to creating more novel designs. And we believe that the idea of social design space exploration can apply across a wide range of design domains. Thank you for your attention, and I'll be happy to answer any questions.